All right, let's go with a couple of more practice problems for projectiles launched at an angle. We'll have some of these as well. Kicking a football from ground level. The initial velocity is 25 meters per second. The angle is 20 degrees above the horizontal. Want to find the hang time. So that's that 2t that we were talking about. That's the total time it's in the air. Want to find the range, dx. And we want to find the max height, delta dy. Alright, those are the three things we want to find. Start out by drawing the vector we're given, 25 meters per second at an angle of 20 degrees. Resolve it into x and y components. I know that the x component is going to be 25 cosine 20, v cosine theta, and the y component is 25 sine 20. Alright, 25 cosine 20, 25 sine 20. X component is 23.5, y component is 8.6. X equals 23.5 meters a second, y is 8.6 meters per second. Alright, here we go. Divide up into x and y. Velocity in the x direction I know is going to be the x component I got, 23.5 meters per second. The distance in the x direction I don't know. That's what I'm looking for, one of the things I'm looking for. And the time I don't know either. We'll go to the y side. AY negative 9.8 always. Time, don't know. For the trip up, VI is our y component that we found, 8.6. And I know that the VF on the way up is 0. And for the trip down, that's also VI, 0. And VF on the way down is the negative of the VY on the way up. So it's negative 8.6 meters per second. Delta D in the y direction is one of the things I want to find. I don't know it yet. Alright, so let's start out finding time just because we can. Our equation that we need to find time, that can be the only unknown that we have in the equation. Therefore, to begin with, we don't care about delta D. And the equation that has time and not delta D in it is VF equals VI plus AT. Alright, and for this one, let's just use the trip down and show you that you can really use either one. It doesn't really matter for most of these. VF on the way down, negative 8.6. VI on the way down is 0. A is still negative 9.8. By the way, negative 9.8 applies to up and down. Hopefully you realize that by now. Time we don't know. That's 0. It goes away. Divide both sides by negative 9.8. Negative divided by negative is positive, which is great because you can't have a negative time. 8.6 divided by 9.8 gives us the time, 0.88 seconds. Alright, but that's not the hang time. Remember, the hang time is 2t, so 2t, the total hang time, is going to be twice that, 0.88 times 2, which gives us 1.76 seconds. Alright, so that's the answer to the first question, the hang time. Ball will be in the air for 1.76 seconds. Not too bad. Now we can do either one of these, okay? Because we can drag that time over here and find the range. And remember, if we're finding dx, we're finding the range, we're going to want the whole time. We're going to want the whole thing. So we can drag that over and say that now time is 1.76. Let's go ahead and work that. V equals d over t. So 23.5 equals dx over 1.76. Cross multiply, because you haven't understood 1 underneath. 23.5 times 1.76 gives me 41.36. And the units are meters. And that's my full answer. I don't have to multiply this by 2, and you might want to ask yourself that. Okay, what time did I drag over here? Well, I drug the 2t. That's the whole thing. So maybe I should have changed this to 2t. 1.76. If I had done 0.88 and put that over here, I would have gotten 20 point something, right? And I would have had to multiply this by 2 because it's only half of the range. The whole range is found if you enter the 2t at the very beginning. All right, so that's my dx. And now I want to find delta d in the y direction. And remember, we can use any equation because we know all the other variables. And let's go ahead and use, let's use the last one, 7. Vf squared equals vi squared plus 2ad. It's not the only one you can use, by the way. You can use any of the ones that have delta d because you know everything else. And let's pick a trip. Let's go trip up on this one, right? You got to pick one or the other. On the way up, and it doesn't matter whether you pick up or down because delta dy is the same height whether you're talking about the trip up or the trip down. Vf on the trip up is 0. Vi on the trip up, 8.6. And that has to be squared. 2. A is negative 9.8, and we want to find delta D. So here we go. 8.6 squared gives me 73.96. 0 equals 73.96 plus 2 times 9.8 is 19.6, and that's still going to be negative. Okay, because one of those is negative. All right. So we have 73.96 plus negative 19.6 delta D. All right, to start to isolate delta D, we've got these two numbers to get rid of. This is multiplied by delta D. This is added. Okay, so we got to do the add subtract first. I'm going to get rid of this one first by subtracting it to the other side. And I'm going to have to move over here. Negative 73.96 equals negative 19.6 delta D. Now we're dividing both sides by negative 19.6. Right? Negative divided by negative will give me a positive. 73.96 divided by 19.6. 3.8. We'll just call it 3.8. Delta D gives me 3.8 meters. Rises to 3.8 meters high. You might think, well, that's not very high. Well, no, it isn't. Usually footballs kicked at an angle of 20 degrees and 25 meters per second usually don't make it just very far, which means they also don't get very high in the air during the flight time. But that's the answer there, 3.8 meters. And it's positive because we chose to work it on the trip up. On the trip up, that's positive velocity and a positive displacement. So that's what we get there. All right, let's work the last problem. A missile launched at a speed of 39.2 meters per second at an angle of 30 degrees to the ground. What's the range? How long does it take to reach the max height? How high does it go vertically? All right, I actually need a little bit more space for this one. All right, so this missile, well, first of all, draw the component or the vector we're given, 39.2 meters per second at a 30-degree angle. Got to resolve it into components first, x and y. X component is 39.2 cosine 30, v cosine theta. Y is v sine theta, 39.2 sine of 30, 39.2 sine 30, 39.2 cosine 30. All right, the sine is the y component, that's 19.6. And the cosine is the x component, 33.9. All right. I forgot to do this. We probably should every time. Range, we're looking for dx. How long does it take to reach its maximum height? Now be careful when you read this because it does say max height. Don't say, oh, I'm looking for delta D. The question says, how long? That's a time. And we're not looking for the total time for this. This is 1t, because if we remember, look at our picture, how long does it take to reach the maximum height? Well, the maximum height occurs right here, and that only takes one trip, which means 1t. Okay, so how long does it take to reach the maximum height? We're finding t, just regular t. And how high does it go vertically? This question is asking for delta d in the y direction. All right, so delta dy, dx, and time is what we're looking for. All right. So we divide it up into x and y. You don't have to start on the x side. I don't know why I always do. Just seems easier. I don't know. Maybe I just do easy stuff first. That's probably a lazy way to do, isn't it? Vx is the x component, 33.9. dx, don't know it. That's one of the things I want to find. T, don't know it. One of the things I want to find. A in the y direction is negative 9.8. T, don't know it. On the way up, Vi is our y component, 19.6. Vf on the way up is 0, and that's also Vi on the way down. Vf on the way down is the negative of what Vy was. Put y's on all these. And that's going to be negative 19.6. Delta D on the way down, well, on the way up or down, doesn't matter. We don't know it. It's one of the things we want to find. All right, so once again, we can't come over here and start with dx. We got to come over to the y side and start with either time or delta d. I just want to show you that you can really do this in just about any order. Let's start with delta dy. Okay, so at this point, these are our two unknowns, and if we start with delta dy, that means time has to be our I don't care variable. So we look for an equation that has delta d and not time. Remember, you don't have to do it this way, but this is one way to do it. Delta dy and not time. So here are our equations here. This is the only one that has delta d and not time. Vf squared equals Vi squared plus 2a delta d. So here we go. Our equation for the first one at least, Vf squared equals Vi squared plus 2a delta d. And remember, we have to pick either the trip up or the trip down. It doesn't make much of a difference, but it would be nice if, well, let's say we want this one to go away, because that way we don't have to subtract it to the other side. So I want the one that has Vi being 0, which would be the trip down. Remember, I can pick either one. It doesn't really matter. So let's go with the trip down. On the way down, Vf is negative 19.6. That's got to be squared. Vi is 0. I'm going to go ahead and put it in there, even though it's not going to mean anything, just for practice. 2a is negative 9.8, whether we're talking about up or down, and I want to solve for delta d. Negative 19.6 is squared, and you might be saying, wait, we can't take the square root of a negative number. No, you can't, but you can square a negative number. Okay, so it's okay if this number is negative. And a negative times a negative will be a positive, so I'm not going to enter the negative into the calculator, even though you can, and you'll get the same answer. I'm just going to do 19.6 squared, and I'll do it the other way just to prove to you that it works. Negative 19.6 squared, 384.16. All right, so we got 384.16 equals 2 times 9.8 is negative, and this is negative 9.8, so that gives us negative 19.6 delta D. Divide by negative 19.6. 384.16 divided by negative 19.6. You can put the negative in or not, doesn't matter. It's going to give you 19.6 for delta D. No, that's not a mistake. That's the right answer. It just happened to work out that way. And again, we got a negative delta D because we chose to do the trip down. On the way down, the thing is coming down. It's got a negative displacement on the way down. Either way, whether you get a negative or positive, it doesn't matter. If you answer the question how high it goes vertically, well, you can say that you can just throw a positive in here and say it goes 19.6 meters up in a vertical direction. All right, so that answers delta dy. Now we still need the time because we still can't come over here and do dx without t. So let's solve for time. And since we know everything else, we can just pick any equation. And the easiest one to solve for time was this one right here. Vf equals Vi plus At. So here we go. Vf equals Vi plus At. Pick a trip, up or down. How long does it take to reach its maximum height was the question. How long does it take to reach the maximum height? Probably most technically we should use the trip up because that question is talking about the trip up. So let's go ahead and do that. And maybe technically we should have used the trip up on the first one as well, but that's okay. It doesn't matter. You get the same thing. On the way up, Vf on the way up is 0. Vi on the way up is positive 19.6. A is negative 9.8. That should probably be in parentheses. And we're solving for t. Solving now, subtract 19.6 from both sides. Negative 19.6 equals negative 9.8t. Divide both sides by negative 9.8. Divided by negative 9.8. Good thing I already had that, right? Gives us 2. T is exactly 2 seconds. Okay, so now I'm going to look up, do I need 1t or 2t? Well, I'm looking for how long it takes to reach the maximum height. Well, that's just half of the trip. So this is what I'm going to stay with. 2 seconds is how long it takes to reach the max height if this happens. Now I can take this time and come over here. All right, I want to know dx. Dx is the range, and remember that the range is the entire thing. So I don't need the time, I need to get 2t. So time is 2 seconds, and 2t would give me 4 seconds. All right, that's what I need to do. Vx equals dx divided by t now. 33.9 equals dx divided by, and the t I'm going to use is 4 seconds because I'm trying to find the total distance, not half of the distance. Cross multiply because you get an understood 1 underneath. Fraction equal to a fraction. 33.9 times 4, 135.6. And there's our final answer for the range of the missile. It goes 135.6 meters, it rises 19.6 meters into the air, and it takes 2 seconds to rise up to that height. It takes 4 seconds to get from one side to the other.